Do you know about dark matter? It's a question that sends shivers down the spine of even the most seasoned astrophysicists. Dark matter, this enigmatic substance, makes up approximately 85% of the universe's mass, yet it remains one of the most elusive phenomena in the cosmos. Unlike the stars and galaxies that light up the night sky, dark matter is a bit of a cosmic wallflower. It does not interact with light or other forms of electromagnetic radiation, which is rather inconvenient for those of us trying to detect it. Despite this, it's not a lost cause. Dark matter may not like the spotlight, but it's not completely invisible either. Just as a gust of wind betrays its presence by rustling the leaves on a tree, dark matter reveals itself through its gravitational effects on visible matter. Despite its elusive nature, scientists have been able to glean some information about dark matter. Let's discover how. The story of dark matter starts in the 1930s with a Swiss astronomer named Fritz Zwicky. Zwicky was a maverick, a man who wasn't afraid to challenge the status quo, and his observations would lead to one of the most profound discoveries in the field of astrophysics. While studying the Coma Galaxy Cluster, Zwicky noticed something peculiar. The galaxies in the cluster were moving at speeds that defied explanation. They were spinning so fast that, under the laws of physics as understood then, they should have been flung apart. Yet they remained bound together in a cosmic dance. This led Zwicky to a startling conclusion. There was more to these galaxies than met the eye. Zwicky postulated that the galaxies were being held together by an unseen force, a hidden form of matter that he termed Dunkel Materie, or dark matter. Dark matter, Zwicky suggested, was the invisible glue holding the galaxies together, exerting a gravitational pull strong enough to counteract the fast-moving galaxies. But proposing the existence of an invisible, undetectable form of matter was a bold move, even for Zwicky. Critics argued that his hypothesis was a convenient fix, a plug for the holes in our understanding of the universe. The concept of dark matter challenged the very foundations of physics, and without direct evidence, it seemed like a leap too far for many in the scientific community. Zwicky, however, stood firm in his belief. He argued that the universe was teeming with dark matter, that it was the scaffolding upon which galaxies were built, and that, without it, the universe as we know it would cease to exist. Zwicky's hypothesis was not immediately accepted. It took decades for the scientific community to come around to the idea due to the lack of direct evidence. Yet, his ideas planted a seed, setting the stage for a quest that continues to this day, the search for the elusive, mysterious dark matter. The first strong evidence for the existence of dark matter came from an unexpected place, the rotation of galaxies. Let's rewind time a bit to the 1970s. A brilliant scientist named Vera Rubin was hard at work, observing the rotation of galaxies. Now, based on the visible matter in a galaxy, scientists expected the rotation speed to drop off the farther away stars were from the galaxy's center. But Rubin's observations threw a wrench in these expectations. She found that the rotation speeds of stars didn't drop off with distance, but rather, they remained constant. This phenomenon is now known as a flat rotation curve. Picture a graph with distance from the galaxy's center on the x-axis and rotation speed on the y-axis. Instead of seeing a curve that drops off, what Rubin saw was a flat line. So, what's the big deal about a flat line? Well, this observation suggested that there was more mass in the galaxy than what we could see. This unseen mass was affecting the rotation speeds of the stars, causing them to move faster than what was expected based on the visible matter alone. This was a clear indication that there was something more out there, something invisible, something we now refer to as dark matter. Rubin's work was groundbreaking. It was like she had thrown a stone into a calm lake, creating ripples that would forever change our understanding of the cosmos. Her research suggested that galaxies are embedded in halos of dark matter, providing the gravitational glue that holds them together. But you might be wondering, if we can't see dark matter, how can we be sure it's there? Good question. The answer lies in its gravitational effects. Dark matter doesn't interact with light or other forms of electromagnetic radiation, making it invisible. But it does have mass, and therefore it exerts a gravitational pull. It's this gravitational pull that influences the rotation of galaxies and gives us clues to its existence. Rubin's work provided the first compelling evidence for dark matter, but what exactly is this mysterious substance? Despite extensive research, the true nature of dark matter remains a mystery. You see, scientists have proposed a myriad of theories about what dark matter could be. Two of the leading theories focus on WIMPs and machos. No, not macho men, but rather weakly interacting massive particles and massive compact halo objects. Let's talk about WIMPs first. These elusive particles are thought to be many times heavier than protons, yet they interact very weakly with other matter. That's why we call them weakly interacting massive particles. They're like the shy heavyweights of the universe, rarely mingling with other particles. Now let's turn our attention to machos. These are not particles, but rather objects, massive ones that emit little to no light, making them difficult to detect. They could be things like black holes or neutron stars lurking in the halos of galaxies. So, why haven't we been able to identify dark matter yet? Well, the main challenge is detection. Both WIMPs and machos are incredibly elusive. WIMPs rarely interact with other matter, and machos are hard to spot because they emit little to no light. However, scientists aren't giving up. They're conducting ongoing experiments in the hopes of detecting these elusive particles and objects. They're using sophisticated equipment, like underground laboratories shielded from cosmic rays and sensitive detectors cooled to near absolute zero. They're also using indirect methods, such as studying the effects of gravitational lensing, where the path of light is bent by massive objects, including potentially dark matter. While these efforts have yet to yield a definitive answer, they have significantly advanced our understanding of the universe. We've come to realize that dark matter, whatever it may be, plays a role in the formation and evolution of galaxies and in the large-scale structure of the universe itself. While we still don't know exactly what dark matter is, we do know it plays a crucial role in our universe. And that's a start. After all, understanding our universe is a journey, not a destination. Scene script. Dark matter, despite its elusive nature, has a significant impact on our universe. Imagine being the backstage director of a cosmic ballet, secretly orchestrating every movement, yet remaining entirely unseen to the audience. That's essentially the role of dark matter in our universe. It's the invisible puppet master pulling the strings, shaping galaxies, and driving the evolution of the cosmos, all while remaining shrouded in mystery. You see, the universe as we know it would look profoundly different without dark matter. It's the gravitational glue that holds galaxies together. Without it, the stars within galaxies would fly apart, unbound by insufficient gravity. But dark matter, with its unseen mass, provides the necessary gravitational pull to keep galaxies intact. It's like an unseen hand, guiding and shaping the cosmos. But the influence of dark matter doesn't stop at galaxy formation. It played a critical role in the early universe, shortly after the Big Bang. Dark matter, being unaffected by light or radiation, could start to clump together into large structures even while the universe was still a hot, dense soup of particles. These structures then served as cosmic scaffolds, around which normal matter could later coalesce to form the galaxies and galaxy clusters we observe today. Moreover, the presence of dark matter is also vital to our understanding of the universe's large-scale structure. The distribution of galaxies across the cosmos isn't random. They're strung out in vast filaments and sheets surrounding gargantuan voids, in a pattern often described as a cosmic web. The structure of this web is determined by the distribution of dark matter. So in essence, dark matter has written the story of our universe. In the grand cosmic narrative, dark matter is a key player, a silent architect shaping the universe from behind the scenes. Yet, it remains one of the most elusive mysteries of modern science. We're still striving to uncover its true nature, to finally bring the backstage director into the spotlight. The quest to understand dark matter is one of the great scientific adventures of our time. So what have we learned about dark matter today? We've journeyed through the intriguing discovery of dark matter by Fritz Zwicky, a leap of thought that stemmed from the observation of the Coma Galaxy cluster. We've delved into the compelling evidence provided by Vera Rubin, whose study of galactic rotation curves provided a cornerstone for the existence of dark matter. We've also explored the leading theories about the very nature of dark matter. Could it be WIMPs, or perhaps axions? The jury is still out, but the quest for knowledge continues, and let's not forget its pivotal role in the universe. Dark matter, invisible yet omnipresent, is the cosmic glue holding galaxies together and shaping the large-scale structure of the universe. As we continue to unravel the mysteries of the universe, who knows what other dark secrets we might uncover? The cosmos awaits us, full of enigmas yet to be solved. Before we wrap up, we'd love to hear from you. If you enjoyed this video and found it informative, show your support by giving it a thumbs up. Your likes help us reach more people, spreading the awe and wonder of the cosmos. And if you're not already part of our community, hit that subscribe button. We regularly upload videos like this one, exploring the mysteries of the universe, from dark matter to black holes and beyond. Don't forget to turn on the notification bell so you never miss an update from us. We're all on this journey of cosmic discovery together, and we're excited to have you with us. Thanks for watching. Stay curious and keep exploring the universe with us.